Good morning, guys. I hope you're well. Today we are introducing trigonometry finally. Okay, this is something that you've probably heard for some time. Some of you may have been scared about trigonometry. Please don't be. We're going to be taking baby steps. We work through very slowly to ensure that you have a full understanding of how to do this. Today we are going to be looking at what trigonometry is, looking at the ratios or the rules and how to choose which rule to use. The next couple of lessons we'll then look at applying those rules to different scenarios. So first of all, if I said to you, what is trigonometry to do with? Mostly the common response might be, and you may have said it, okay, you may know that's to do with right angled triangles. Now, we've just finished off something already that has to do with right angled triangles, and that would be Pythagoras' theorem. So just for example, you may have had a triangle with 3 and 4, and you're asked to go and find x. Remember, it can only work for right angled triangles. So you would have done something like this. X squared equals 3 squared plus 4 squared. You'd say x squared equals 25. You'd say x is equal to 5. Fantastic, nice and easy. You've done that load since year 8. But what if I gave you a similar question, like this, for example, but I took out one of the values? Now, what you'll notice that Pythagoras' theorem no longer works. We have a 3, we have an x, but we have another unknown. How can you solve an equation with two unknowns? You just can't unless it's a simultaneous equation, which this clearly is not. So we can't use Pythagoras. But you will now also note that there's an added in angle of 40 degrees. So in this instance, we can use trigonometry to form an equation to help us solve that. But of course, we need to know what those rules or equations are going to be. We don't know that just yet. So I'm going to take a bit of a side junket. I'm going to draw a triangle, and I'd ask you to draw this out. I'm going to label this as triangle A, triangle B, and triangle C. You might remember back to year 7 or year 8 where we had labeling of sides. For example, the hypotenuse here could be called the side AB, but it could also be called little c because it's opposite angle C. Likewise, the side BC, which is the horizontal, could be called little a because it's opposite the big A. And then the side AC could be called little b. Now, why have I done that? Because when we're looking at trigonometry, labeling is really significant. Now, of course, you can see the Pythagoras kind of works here. A squared plus B squared equals C squared. Now, I'm going to put a little angle in where B is called theta. Remembering theta, okay, just means a symbol for some type of angle. It's got to be acute because it's in a right angled triangle, okay? We could use alpha, okay? It's another one that we often use. We could even use one called beta, okay? I could even use x, y's, and z's, to be honest, or angle B. But we're going to use theta. Now, what they worked out a long time ago is that if they use, remember that little button on your calculator that says sine, and you would have seen cos and you would have seen tan for many years? Well, this is where this comes in, right? If they found the value of that angle and then they knew all the three sides, let's say, for example, the sine 40 degrees in our other triangle, they worked out if they typed in sine theta and found the number or the value of it, that was exactly the same as doing the division of the sides B and C. They gave the exact same value. Might not like kind of jump out at you why it's really cool, but it is really cool. Likewise, if they did cos angle, whatever it might be, like cos 40 degrees, that gave the same exact answer as dividing the A and the C together. And likewise, if they typed in tan and that angle of 40 degrees, or whatever it might be, it will be the same as doing the B divided by the A. Now, you might go, okay, that's kind of cool. I don't really get that so far. But how do you know what A, B, and C are? So if we look back at the example that we've got on that left-hand side, you know, what are the X's and the 3's in terms of the B's and the C's and the A's? It has no meaning to me. So what they then looked at and said, okay, well, let's give them names. Let's label them. So for example, the C is the easiest one to do, right? Because it's called the hypotenuse. It's always the hypotenuse. It's always the longest side. So I'm going to call that the hypotenuse. And you can see two of my rules use the hypotenuse. If I look at the side B in regards to theta, what do you notice about the B? It's opposite to the angle. So I'm going to call that the opposite. If I look at the A in regards to theta, it's next to it, isn't it? So we call that the adjacent. Adjacent means next to. And likewise, we've got B and A. Well, we've already labeled those two as opposite and adjacent. Now, again, don't worry so much if that doesn't kind of pop out to you. We're going to see how this all works. Now, what I might just do, I might just quickly show you a real quick example. I'm going to use a nice isosceles triangle just to show you an example of this happening. I'm going to put this as 45 degrees because it's an isosceles triangle, so 45 and 45 makes 90. Now, if we used a bit of Pythagoras just to solve this out, we'd get 3 squared plus 3 squared equals x squared. We'd get, what's that going to be, 18 equals x. X squared, we get x equals root 18. So I just worked out what that was. Now, I'm just going to show you, using a triangle, how this kind of works out. So let's say, for example, we find the value of sine theta. Now, the rule says sine theta equals opposite over hypotenuse. Now, in our triangle, we have the 45 degrees there. So sine 45 equals, the opposite is the 3, and the hypotenuse is the root 18. Now, on my calculator, I'm going to type in sine 45 and press equals. And it says 0.7071 ... Okay, I'm now going to type in 3 over root 18. And hopefully, if we've done this right, look at the answer. 0.7071 ... They're the exact same thing. Now, you might say, again, I don't really see, okay, they're the same. That's cool. Is that just by chance, or, how's it even going to help me? And this is how it's going to help you. If I know, for example, what the angle is and what one of the sides are, I can use those two pieces of information to find the third. And that is really important. If we go back to that initial example we've got here, okay, with the 40-degree triangle, if I can label these two sides as either the adjacent, the hypotenuse, the opposite, and work out which of the three rules to use, I can form an equation. So let's have a look at it. We've got the 40 degrees. X, we already have spoken about, it's the hypotenuse. What about the 3 though? Is that the adjacent or is that the opposite side? Well, hopefully you might say that's the adjacent side because it's next to. The opposite side, well, there's nothing labeled and I don't want to label it. Which of those 3 rules, sine, cos, and tan, use both the adjacent and the hypotenuse? Hopefully you can see it's that cos rule, or cosine it can be called. So what we could actually do is just use this rule, cos theta equals the adjacent over the hypotenuse. Now we know that the theta is 40 degrees. We know that the adjacent is 3, but we don't know what the hypotenuse is. But what you now have done, you have formed an equation which later on we can solve. For example, we could times the x across, divide by the cos 40, and on our calculator we could calculate that out. I'm not interested in that at all. Okay, I'm just interested to show you how this kind of works. What are the main things that I want to get out today? And this is the thing, you might be getting a bit overwhelmed by all this information, but this is the number one thing that you need to learn today. SOHCAHTOA. SOHCAHTOA. It helps you to remember these rules. Number 1, we need to know what this is. Number 2, we need to be able to label a triangle to figure out which of these two things do I have. Do I have the opposite and hypotenuse, the adjacent and hypotenuse, or the opposite and adjacent? And number 3, we can then figure out which rule goes with which triangle. Now, SOHCAHTOA is simply a mnemonic to let me remember we have sine is opposite and hypotenuse. Cos is adjacent and hypotenuse. And tan is opposite and adjacent. SOHCAHTOA. Okay, just got to spell it correctly. There's no C and K. It's not a sock. Okay, SOHCAHTOA. Now, that's number 1. Number 2, we want to be able to label my diagram. So for example, if I gave you a different question like 15 degrees and I threw an X in here and I threw a 20 centimeters here, for example, would you be able to label this triangle with either adjacent, hypotenuse, or opposite. And that's important. So in regards to this question, look at the 20. Well, that's always going to be the hypotenuse, isn't it? Always will be. But the 15 is opposite to the other side that's given. So, or the x is opposite to the 15. So that's called the opposite side. Now, clearly you can see that the last side that's not labeled would be called the adjacent side. However, there's no need to label it because we don't really care about it, right? We only care about the x and the 20. So out of my rules, I'm going to write this out again. So, ka, toa. Remembering it's sine, cos, and tan. Which of the two sides have I been given or have I been asked to look at? Well, I'm using opposite and hypotenuse, which we can see is this sine rule. So, which means sine theta equals the opposite value over the hypotenuse value. Now, that's the first thing. If we can identify that, we are doing really well, okay? The last thing that I want out of today's lesson is I want you to sub the values in, which once you have the rule, that should not be hard. So, instead of having theta, we're going to type in 15 degrees. Opposite, we're going to put in the x, and the hypotenuse, we're going to put in the 20, and that's all I want. That is all I want for today, okay? To be able to write that out. Next lesson, it's about how now to calculate the x. Now, usually, of course, opposite divide by 20 is times by 20. Okay, do 20 sine 15, go from there, but that's tomorrow's lesson. First of all, learn your rules. So, ka, toa. Second of all, label your diagram, opposite, hypotenuse, adjacent. Third, choose the appropriate rule. Job done. Okay, job done. EG1. Okay, now feel free to kind of pause this. I'm going to put that as 15 and we'll put that as x. Now, with these questions, actually, you know what? I might actually put that as a number. We'll put 60 degrees there. We can only do these with right-angled triangles, by the way. They only work right-angled triangles in this case. Non-right-angled later on, we have to have a different rule. Okay, 60 degrees. Again, we're going to do 2 centimeters and 8 centimeters, and I'll do a third one. And we'll have an alpha this time. Actually, no, I won't have an alpha. I'll have an actual value. We'll have 40 degrees. We'll have x, and we'll have 16. Okay. So pause it. See if you can come up with the 3 things I spoke about. Write the rule down. Locate what side you have, a label of sides, and identify the rule and apply it. Don't solve it, but apply it. See you in a bit. How'd you go? Okay, first one. I'm going to write up the top here. S-O-H-C-A-H-T-O-A. So, ka, toa. Okay. Example 1. In regards to 60 degrees, you have the hypotenuse side and you have the adjacent side, the next two. They're my 2 things I've got. Which rule uses A and H? It is the cosine. Cosine. I know we call it cos, but actually it is the cosine. Okay, but we call it cos. So I'm going to write down cos theta equals A over H. Now, you don't need to write that. If you want to sub into it straight away, then go for it. But I want to see cos 60 degrees equals my adjacent, which is 15, over my hypotenuse, which is x. That's what I want to see every single time. Perfect. Job done. I want to solve it. Don't care about solving it. Just want that expression. Next one. Okay, we have the opposite side. We have the adjacent side. We do not have a hypotenuse. So which uses the opposite and the adjacent? Out of my rule, TOA does, T-O-A. So tan theta equals my opposite over my adjacent. We can say tan 60 degrees equals, now my opposite is 8 and my adjacent is 2. Okay, that time I gave you values there. All right, should say an X there, but it doesn't. There you go. That's all I want. Done. Okay, that will be incorrect because that equals 4. So I should have put that as an X. Let's just change that just so I'm more correct. There you go. Okay, 8 over X. So that's how it should look. Okay, that's all I want you to do. Don't solve it. Just locate the rule. The last one. We have the opposite side. We have the hypotenuse side. Opposite hypotenuse, sin or sine. So sine theta equals opposite over my hypotenuse, SOH, okay? So that's SOH. You can see how that works. So I'm going to apply it. Sine 40 degrees equals my opposite over my hypotenuse, and job done. Nothing else to go. Okay? That is it. That's all I want out of from today. Now, I'm going to do a short video after this about how to use your calculator to calculate some of these values. Most of that should be pretty straightforward. But for me, number one, go and learn SOHCAHTOA. Okay, know that SOH is sine is opposite over hypotenuse. CAH adjacent over hypotenuse. Tan is opposite over adjacent. Be able to label your diagram as either opposite, adjacent, or hypotenuse. Really important. Label just two of them. And then, of course, then apply that to the rule. Okay, and then next lesson, we'll look at actually how to calculate that. Have a wonderful day.